Hello and welcome to the Advanced Software Architecture course. My name is Imed Hammouda. This is a lecture on architectural styles, part 4. In this lecture, we will continue our discussion on component and connector architectural styles. We will cover broker, ModelViewController, publish-subscribe, peer-to-peer, and service-oriented architecture. We will start with broker. The broker style defines a runtime component called a broker that mediates the communication between a number of clients and servers. It can be used to structure distributed software systems with decoupled components that interact by remote service invocations. A broker component is responsible for coordinating communication such as forwarding requests as well as for transmitting results and exceptions. Three main components are involved in a broker system: the broker, the server, and the client. The broker is the message routing component of your system. It passes messages from client to server and from server to client. These messages are requests for services and replies to those requests, as well as messages about exceptions that have occurred. The requests are coded as calls to the broker's API. The broker is responsible for error handling in response to these exception reports. The second component is the client, which is a requester of services. The third component is server, which is a provider of services. Broker separates users of services or clients from providers of services or servers by inserting an intermediary called a broker. When a client needs a service, it queries a broker via service interface. The broker forwards the client's service request to a server, which processes the request. The service result is communicated from the server back to the broker, which then returns the result back to the requesting client. The advantages of this architectural style are mostly related to the fact that client remains completely ignorant of the identity, location, and characteristics of the server. Further, the style allows for higher interoperability by providing communication protocols and interfacing mechanisms between clients and servers. Also, the style scores high on flexibility, as servers can be changed transparently to clients. On the downside, brokers add complexity and a level of indirection between a client and a server, which will add latency to their communication. Broker would be an obvious point of attack from a security perspective, and so it needs to be hardened appropriately. Here is a question for reflection. Discuss the case where multiple brokers are used to provide a single logical service. In the example shown on the slide, you see two MQTT brokers talking to each other via a bridge. The two ends decide on what data is allowed to be exchanged between the two parties. Next, we discuss ModelViewController. The ModelViewController, or MVC, style separates the modeling of the domain, the presentation, and the actions based on user input into three separate logical elements. First, the model manages the behavior and data of the application domain, responds to requests for information about its state, usually from the view, and responds to instructions to change state, usually from the controller. Second, the view manages the display of information. Third, the controller interprets input from the user, informing the model and/or the view to change as appropriate. It is important to note that both the view and the controller depend on the model, However, the model depends on neither the view nor the controller. ModelViewController thus separates application functionality into three kinds of components: a model which contains the application data, a view which displays some portion of the underlying data and interacts with the user, and a controller which mediates between the model and the view and manages the notifications of state changes. On the advantages side, because these components are loosely coupled, it is easy to develop and test them in parallel, and changes to one have minimal impact on the others. This in turn contributes to reuse, extensibility, and scalability levels of the system. On the limitation side, it is regarded that MVC is not appropriate for every situation. The design and implementation of three distinct kinds of components, along with various forms of interaction, may be costly, and this cost may not make sense for relatively simple user interfaces. The other main limitation is reduced system performance if the number of messages between system components is too high. Here is a question for reflection. Use a sequence diagram to illustrate an example communication scenario between model, view, and controller. Here is a typical scenario. A request is received from a web client via a view component. A designated controller is used to handle the request by querying the model for requested data. The appropriate data is then returned by the model to the controller, gets validated, and is sent further to the appropriate view element. The view is then updated and the user is notified. Next, we cover publish, subscribe. In software architecture, publish, subscribe is a messaging style where senders of messages, called publishers, do not program the messages to be sent directly to specific receivers called subscribers, but instead characterize published messages into classes without knowledge of which subscribers, if any, there may be. Similarly, subscribers express interest in one or more classes of messages and only receive messages that are of interest, without knowledge of which publishers, if any, there are. Hence, the style consists of component elements with at least one publish or subscribe ports and a connector element which has announce and listen roles for components that wish to publish or subscribe to events. It is the job of the connector element to make sure that each published event is delivered to all subscribers of that event. The advantages of the style include loose coupling. Publishers are loosely coupled from subscribers. Scalability. It is possible to scale up the system regarding the number of publishers and subscribers. Extendability. It is possible to extend the system with new features modeled as subscribers or publishers. Finally, security gets improved in the sense that messages are sent to interested subscribers only. The limitations of the style include the complexity of guaranteeing the delivery of messages and performance problems due to overhead associated with message delivery, especially when the system is overloaded with messages. Here is a question for reflection. Can you see any connection between MVC and publish subscribe? MVC-based applications may employ publish subscribe where view components are notified when the state of a model object changes. Next architectural style is peer-to-peer. In the peer-to-peer style, components directly interact as peers. All peers are equal and no peer or group of peers can be critical for the health of the system. Peer-to-peer communication is typically a request-reply interaction without asymmetry found in the client-server style. Examples include torrents and file-sharing systems. Peers first connect to peer-to-peer network on which they discover other peers they can interact with, and then initiate actions to achieve their computation by cooperating with other peers by requesting services. Therefore, the style consists of component elements which are independent peers running on a network node. Special peer components can provide routing, indexing, and peer search capability. A connector element is used to connect to the peer network, search for other peers, and invoke services from other peers. On the advantages side, typically multiple peers have overlapping capabilities, such as providing access to the same data or providing equivalent services. Therefore, if one of these peers becomes unavailable, the others can still provide the services to complete the task. The result is improved overall availability. There are also performance advantages. The load of any given peer component acting as a server is reduced, and the responsibilities are distributed. Further, peers can be added or removed from the peer-to-peer network with no significant impact, resulting in great scalability for the whole system. On the limitations side, however, the drawbacks of peer-to-peer style are strongly related to its strengths. Because peer-to-peer systems are decentralized, managing security, data consistency, data and service availability, backup and recovery get all much more complex. Here is a question for reflection. Client-server and peer-to-peer are two different types of network architecture. Can the same system have both topologies? Think, for example, of Skype. It is a peer-to-peer IP telephony network that uses a central login server to authenticate peers. Last component and connector architectural style we discuss is service-oriented architecture. A service-oriented architecture is an architectural style in software design in which application components provide services to other components via a communication protocol, typically over a network. The principles of service orientation are independent of any vendor, product, or technology. A service-oriented application is an application composed mostly of services which are often in a hierarchy. Computation is achieved by a set of cooperating components that provide and/or consume services over the network. Major components of the service-oriented architecture are service providers, which provide one or more services, consumers, which invoke services directly or through an intermediary. Service providers may also be service consumers, enterprise service bus, which is intermediary element that can route and transform messages between providers and consumers, registry of services, which may be used by providers to register their services and by consumers to discover services at runtime, orchestration server, which coordinates the interactions between service consumers and providers based on language for business process workflows. Connectors can be SOAP connectors, REST connectors, or asynchronous messaging connectors. On the advantages side, the main benefit and major driver of SOA is interoperability. Because service providers and service consumers may run on different platforms, service-oriented architecture often integrates a variety of systems, including legacy systems. SOA also offers the necessary elements to interact with external services available over the Internet. Regarding limitations, service consumers are connected to service providers, but intermediary components may be used. You don't control the evolution of independent services. SOA-based systems are typically complex to build. There is a performance overhead associated with the middleware, and services may be performance bottlenecks and typically do not provide performance guarantees. Here is a question for reflection. Which architectural tactics are most relevant to service-oriented architectures? Think of interoperability tactics. This is the end of the Architectural Styles lecture part 4. Thank you for watching.